Hello, researchers. Welcome to our lecture series on research. In today's lectures, we are going to discuss something important about one of our research article that's been published in RSC Advances. So the titles of the articles you can see it here that we are going to discuss today is the cytotoxic and photocatalytic studies of hexagonal boron nitride nanotubes that is about a potential candidate for wastewater and air treatment. I mean, that is our work that's been published in RSC Advances. So, what actually we have done in this, in this research work, what is the importance and how the audience could follow to further enhance their strength and the similar field. So, let me give you some detail about these articles, and maybe you can do the rest of research by yourself to do more in the same field. So what actually we have done is we have prepared, we have synthesized boron nitride nanotube and this work, and then we tried and test the materials for its potential applications and the treatment of the water. I mean, you know that clean water is a problems that being faced by the world nowadays. So what actually we done? So first of all, in the introduction, we gave a history of and history and importance of the boron nitride nanotubes. We discussed about the procedure that how the people prepared boron nitride and boron nitride nanotube throughout the history. And then we also discuss about the importance of the boron nitride nanotube towards many applications that the people have performed in the last few decades. And we also discuss the potentials of the boron nitride nanotubes towards the current study. So after a brief introductions, we focus towards the experimental details. So in experimental details, you can see here, so we have different sections, and the first sections here, you can see that section number 2.1 is the material method sections, and this section we just talk about we discuss about the procedures. That's how we prepared boron nitride nanotubes, or you can say the easy word, the scientific word is the synthesis of boron nitride nanotube. So it's the sample procedures about the synthesis of boron nitride nanotube. So it's given in the material methods. Then we characterize the synthesized material. I mean, here you can see, you can check the recipe for yourself. It's the recipe and the procedure for the synthesis of boron nitride nanotube. Then we have we use different characterizations technique to analyze the content, the morphology, and many things about the synthesized material. So we use the technique that we use for the characterizations about synthesized materials are field emission, scan electron microscopy. We utilize X-ray photoelectron spectroscopy, XRD, and Raman, etc. They're being utilized to characterize the synthesized nanotubes. Then in section number 2.3, we prepared the cytotoxicity essay. I mean, the details are given here. We are not going to full detail. You have to study you have to study the detail for yourself. I mean, the essay preparations for the cytotoxicity is given here. So it's the full details, and this is some of the history, some of the formulas that have been involved in preparing the cytotoxicity essay. Then we proceed towards the photocatalytic activity. So the detail of photocatalytic activity is also given here in section number 2.4. So you can study this in detail. So you can also, clarify your concept. So then we go into the result and discussions. So here you can see in section number 3, we start with field emission scanning electron microscopy analysis. That's technique we just analyze that how our samples or how our synthesized nanotube will look like. So here you can see the details, the detailed micrograph, the epicenter micrograph, and different magnifications. That give a sense that how and different magnifications or synthesized nanotubes look like. Then after that we proceed about the content. I mean that what is the specific content on the surface of the synthesized nanotube. So we perform different characterizations tools. I mean here you can see the first tools that we utilize to check the contents or the contents, or you can say the constituents of the nanotube. So for that we perform the X-ray X-ray is the X-ray diffraction. So here you can see the X-ray graph, the X-ray spectrum. So X-ray spectrum give you a sense that what's the major content of the synthesized nanotube. So it's basically boron and nitrogens with the hexagonal phase. To further clarify this, so we perform also the XPS, X-ray photo electron spectroscopy. You know that it's a surface sensitive technique that give you the contents on the surface of the samples, because you know that at the nanoscales the materials mostly lie at the surface as compared to the volume. So XPS is the best technique that gave you the sense that what actually is being contained by your sample at the surface. So according to the XPS, the major content of our sample in the surface is boron and nitrogen, that clarify the 1:1 ratio, and also clarify the boron and nitrogen content of the hexagonal boron nitride. Then we further clarified the concept with the Raman spectroscopy, and Raman spectroscopy almost have the same research. I mean it's the clarifications about boron and nitrogen content with the hexagonal boron nitride nature of the synthesized nanotubes. So after clarification about the content and the morphology of the synthesized nanotube, we proceed toward the cytotoxicity analysis. So here you can see the graph. You can easily study here the details of the cytotoxicity analysis. And you can also see the graph here. From the graphic analysis you can easily find the performance of our materials for the cytotoxicity analysis. So it's the best results ever been reported for boron nitride nanotube for cytotoxicity analysis. You can watch it here by yourself, and you can also study the article for more detail. And after that, we proceed toward the absorption spectra of the methylene orange dye on the BNT surface. Uh, we perform the photocatalytic dye degradation analysis of the synthesized nanotube. So here you can see the absorption spectra of methylene orange dye on the BNT surface. And after that we also do the photocatalytic dye degradation by BNT in term of initial concentration of dye, that is from 5 to 50 ppm, and the second you can see it here, and B the amount of the catalyst from 0.1 to 0.5 gram. And here the C you can see that we also change the pH here, and you can see we have pH and the radiation time here has been mentioned here. I mean the detail you can you can study by yourself, and you can ask the questions if there is anything you're unable to understand. And then you can what actually we concluding from this work is given in the conclusions. It's excellent articles. You people will like it, very much interesting. You should read it. And if there is something that you're unable to understand, you are unable to get, or you further want to do in this field, so you can easily contact us. The detail of the correspondence authors given here. So you're most welcome to contact and for further discussions. Hope you enjoy the article. See you with more article very soon. Till then, bye bye.